How do 3D printer slicers turn models into G-code? It all begins in the source file, often created in a CAD software. The parametric file is converted into a stereolithography file full of triangles. Those triangles are formed from the points of the parametric file with important geometry and are methodically connected with edges to form a mesh of triangles. The slicer uses planes to intersect these triangles. If the triangle doesn't intersect at all, the slicer ignores it for the active layer. If just one node intersects the plane, the slicer also ignores it. If two edges or a node and an edge intersect the plane, that forms a useful contour segment between the two intersection points. Lastly, if the entire triangle is within the plane, that is also ignored by the slicer, as other triangles will define the relevant geometry. Those contour segments are then stitched together where their endpoints overlap to form closed loops. That process is repeated for every layer to determine what portions of the model actually require printing. This forms many layers of two-dimensional geometry for the slicer to build toolpaths within. The toolpath generation begins with walls, which begin on the sliced edges and are offset inwards. Then, depending on the layer and the geometry above or below that layer, an infill is created with alternating directions between layers. Central layers can have lower infill if structure is unimportant, which saves material. As the toolpaths build, they are cognizant of the geometry above and below them to determine if more infill is needed, as exposed surfaces should have full infill. Most slicers then use an algorithm to assign G-code to the toolpaths. My application uses simulation to generate the G-code so my multiple printheads can avoid collisions. Hopefully you learned something and I answered the question,